between two curves. As you can observe here on the board, the three figures. In first figure, there are two curves which are not intersecting with each other. In second figure, we have two curves which are intersecting with at one point. Now, in both cases, there is no area which is bounded. The open area is there. In second figure, you can observe at a point of intersection between two curves, the right hand side area or left hand side area or up area or down area which are not bounded, that means they are open, so we cannot calculate this area. But in second figure, as we observe, there are two curves intersecting each other between 2 points. Then the region which I shaded here is a bounded area. Now if there are two curves intersecting to each other between 2 points, then and then only we can find area between two curves. So we have to here two curves which are intersecting each other between 2 points, and the region they bounded which we have to evaluate here. For that, we take this curve in coordinate system. As we know, in coordinate system, the curve has a relation between x and y, which is the equation of curve. Now the first curve, I say here y1, which has the equation f of x, and this is the second curve which I took as a y2 is equal to g of x. For notation, we take here y1 and y2. Okay, and as you observe here, the point of intersection between 2 points, we can plot parallel lines to y-axis. As there are 2 points of intersection, so we get two parallel lines to y-axis. As these are the vertical lines, so the equation of lines are x is equal to a and x is equal to b. As x is equal to a is the distance between origin to point of intersection of line on x-axis is a, then equation of line x is equal to. Similarly for second, actually we have to find this area. As you learn in first application, area under the curve between two vertical lines. Now for first curve, as we see here y1, actually I change the notation here. I take this as a y1 and this as a y2. This is notation only. Now the first curve is now y1. The area bounded by y1 with respect to x-axis between these two vertical lines a and x is equal to a and x is equal to b. I represent it as a a1. A1 is the area from integration a to b by first curve, which is put by y1 here into dx. As with respect to x-axis we find. Similarly, the second curve, which is a y2, also bound the area with x-axis between these two vertical lines a and b. As it is represented by a2, so a2 is the integration from again between a to b by curve y2 with respect to x-axis. Now, as you observe here, as a1 is this a total area, okay, by first curve bounded with x-axis between a and b, and now y2 is a area which is bounded here by a2 is the area which is bounded by second curve, which is now here. As you understand here, the area which we want to evaluate is this region, which is represented by a, and a is equal to here a1 minus a2. That means total area minus this area bounded by second curve. Okay, so we get this area, which is the area between these two curves. As a1 is integration from a to b y1 dx, a2 is integration from a to b y2 dx, we can subtract these integrations which are on right hand side. So as they have same limits, so we take common limit as a to b and put y1 minus y2 with respect to x. So a is equal to, that is required area between two curve is equal to integration from a to b y1 minus y2 dx. As we can put y1 as f of x, g of x, and y2 is equal to f of x. So required area A is equal to integration from a to b f of g of x minus f of x into dx. That is subtraction of equations of curve from integrated from point of intersection of between two points x coordinate a to b with respect to x. Find area between two curves y is equal to x square and y is equal to x. As you can observe here in example, we have given two relation between x and y, that means given two equation of a curve. As you understand in the first application, area under the curve, we have given only one curve, that means one relation between y and x, and limits in which we have to find the required area, and which we evaluated by taking integration from this a to b with limits a to b, the equation of curve with respect to x. This is the area under the curve. Now as we are given here two curves, from in between these two curves we have to find the area. As we know, if the two curves intersecting each other, 2 points between 2 points, then and then the area is a bounded or region is a bounded which we can evaluate it. So in this example we have to find first point of intersection, as these are the given equations of the curve. So we put first the equation of given curve, that is given curve, as first curve is y is equal to x square. As you can observe, this is a equation or function is in explicit form, that is y is put into term of x. So we can use it as to find area, as we use only explicit functions to evaluate, to take integrations. Now second equation of curve is y is equal to x. This is again an explicit function. To find point of intersection between these 2 points, we solve this example from 1 and 2. Which two equations we have to solve? The left hand side of both equations are equal, so right hand side we can equalate, that is we get x square is equal to x. From this equation we can form a polynomial. For that we take x on left hand side, so we get x square minus x is equal to 0. Now solving by factorizing this equation, we have to factorize this expression. As these both terms are a term of x, so we take x as a common, so we get x minus 1 as a second factor, as x is equal to 0 or x minus 1 is equal to 0. So we get the two values of x is equal to 0 and x is equal to 1. These two are coordinates of point of intersection between these two curves, as the area which we have to find between these two vertical lines from 0 to 1. So we can say that now area between two curves A is equal to, the point of intersection are 0 to 1, so we have to take limits as 0 to 1. Now we have to take y1 minus y2 into dx, that is subtraction of equation of curve. Now y1, as we put y1 is a explicit equation of curve of first curve, which is a y is equal to x square, so we put y1 as x square and take subtraction, and then equation of a second curve which is a y is equal to x, so we put as x into dx. Now this simple integration we have to evaluate. As there is a subtraction, we take separate integration of each term. The first integration of x square from integration from 0 to 1, second term is x with respect to x, as integration of x square is x cube by 3, as it is a power function from 0 to 1, minus integration of x is a x square by 2 with limit 0 to 1, as 1 by 3 is a constant. Now again the limits are 1 and 0, that in power the value power of 1 is always 1, so upper value become 1 and power of 0 is always 0, so lower value is become 0. And in second bracket also, second term also 1 by 2 is a constant, so we take as upper value, as upper limit 1 is a 1 and lower value as a 0. Now simplifying by 1 by 3 into 1, we get 1 by 3 minus in second 1 by 2. Now subtracting this simple expression as 2 into 1 2, minus 3 into 1 3, 2 minus 1 2 minus 3 minus 1 by 3 by 2 6. Remember, area is always positive, as here we get negative value, but we put it as a positive 1 by 6 square unit. Find area of region included between y is equal to x square plus 1 and y is equal to x plus 1. As these are the two curves, between these two curves we have to find area. So we took first the equation of curve, that is given curve. First curve is y is equal to x square plus 1. As this is the equation in explicit form, so we take it as it is. And second equation is also y is equal to 2x plus 1, which is again explicit function. Now first we have to find the point of intersection between two curves, as we are evaluate here area between these two curves. For that we solve these two equations from 1 and 2. As we observe, on left hand side the equations are equal, so right hand side we take as equal. So x square plus 1 is equal to 2x plus 1. As we have to form equation, so we can evaluate the factors of this equation. For that we take this right hand side on left hand side. So on left hand side we get x square plus 1, this plus 2 become minus 2 and plus 1 become minus 1. As plus 1 minus 1 get cancelled, we have only term of x square, which has first factor as x and second factor as x minus 2. Now x is equal to 0 or x minus 2 is equal to 0. So we get the two values of x. First is a 0 and second value is a 2. As these are the two point of x coordinate of point of intersection between these two lines, which are the limits of our required area. So area between two curves A is equal to, the area has a limit as a lower limit 0, upper limit to y1 minus y2 into dx. Remember this form. Now y1 is a equation of first curve, which is a term of x as x square plus 1. So we put as x square plus 1 in the bracket minus y2 is again equation of a second curve in term of x, which is a 2x plus 1. Now we have to first simplification of this subtraction. We take out the bracket, so first term will be x square plus 1. As we take out second bracket, it has a minus sign, so first term become minus 2x and plus 1 become minus 1. Remember this simplification. As plus 1 minus 1 get cancelled, so we again in integral had two term x square minus 2x. Now we have to take integration separately, as there is a subtraction. So we take integration of x square with respect to 2x, and in second term 2 is a constant, so we take it outside integration. Integration we get only x. Now we take the simple integration of first term x square as integration x cube by 3 with limit 0 to 2 minus 2 into, as second term x has integration x square by 2 with limit again 0 to 2. Now 1 by 3 is a constant. Now upper limit is a 2, so upper value is 2 to 8. Lower limit is 0, so lower value becomes 0. As 2 get cancelled, we get upper value as upper limit 2 square is a 4 minus lower value is again 0. So 8 by 3 minus 4. For simplifying this, 3 into 4 12, 8 minus 4 minus 4 by 3 is our answer. But we know the area is always positive, so we get A is equal to 4 by 3 square unit. Find area between two parabolas y square is equal 9x and x square is equal to 9y. As in solution we take given curve, as first curve is y square is equal 9x, which is the equation of x and y, as this is the explicit function of y only, as here y is a function. Now we have to take to evaluate area explicit function of x. So by simplifying this, by taking square root on both sides, we get y is equal to 3 root of x. So this is now explicit function of y in term of x. This is the first curve, and second curve is given equation x square is equal to 9y. This is the explicit function of x, but we have to separate y. So we take 9 from right to left. It came into denominator, so we get y is x square divided by 9. Put this as a number 2. Now we have to solve this equation to find the point of intersection between these two curves. So from 1 and 2, add equation 1 and equation 2 having left hand side equal, we equate their right hand side. In equation first we have 3 root x on right hand side, and equation second we have x square by 9. Now as we know, we have to solve this equation for find two values of x. So that we have to factorize this, as this expression contain radical sign. So we first simplify this radical sign by taking square on both sides, as we have on both sides root sign on left hand side. By taking square on both sides, we get 3 roots of x is a square x, and on right hand side, as numerator square will be x raised to 4 and denominator is a 81. By taking 81 on left hand side, in multiplication 9, we get 729x is equal to x raised to 4. Now again simplify. Now with for to evaluate factors, we have to make this equation in form having 0 on right hand side. So that I take 729x on right hand side, so we get left hand side 0, and then interchange the terms, we get the equation in form x raised to 4 minus 729x is equal to 0. These are the terms of x. So one factor of these terms is x, so second factor will be x cube minus 729. As we need two factors, so first factor x is equal to 0, or second factor x minus 729 is equal to 0. That means x cube is equal to 729. And we know the number 9 has the cube 729. So cube root of x is x and cube root of 729 is a 9. So x is equal to 0 and x is equal to 9 are two x coordinates of point of intersection between given two curves. So the area between these two curves has a limit from 0 to 9. So area between two curves a is equal to from 0 to 9 y1 minus y2 dx. As we know, we have to put in integration. The y1 means the equation of curve in term of x, which is a 3 root x, and y2 is a equation of second curve in term of x, which is a x square by 9. Now we have to take integration of this subtraction, as 3 is a constant, so we take it outside integration. In integration, we get x raised to half, as radical sign is converted into index form, and minus in second term 1 by 9 is a constant. From integration 0 to 9, we get integration of x square dx. Now simple integration we have to take. In first 3 x raised to half as integration x raised to 3 by 2, as index 1 half plus 1 is a 3 by 2 divided by 3 by 2 with limit 0 to 9, and minus in the second 1 by 9 as constant, x square has the integration x cube by 3 with limit 0 to 9. Now this 2 take outside this bracket, 3 by 2 take outside bracket, as 3 get cancelled, we have 2 in numerator only, and now we have to find 9 raised to 3 by 2, which we can simplify as the 9 raised to half raised to 3. Actually 9 raised to half is a 3 cube is equal to 27. So 9 raised to 3 by 2 is a 27. So upper value will be 27 minus lower limit is a 0. So lower value becomes 0, as power of 0 is always 0. And in a second expression, as 1 by 9 into 3, 27 is a constant outside, as upper limit is a 9, so upper value is 9 cube is equal to again 729, and minus lower value is a 0, as lower limit is a 0. Now simplifying this, 2 into 27 is a 54, and minus, as 9 cube is equal to 729, similarly 27 square is also 729, so we get 729 divided by 27 as a 27. By subtracting, we get answer 27 square unit. Find area bounded by parabolas y square is equal to 4x and x square is equal to 4y. And here in example given curve R, the first equation is a y square is equal to 4x. As you can observe here, this is a implicit rather this is a explicit function in term of y, as there is a function of y only, but we take the function y in term of x, that is explicit function of x. So taking square root on both sides, we get y is equal to, on right hand side we get 2 root of x. Put this as a number 1, and the second equation is a x square is equal to 4y. This is a explicit function of x, but we have to separate y here, so we take y as this 4, take on denominator of left hand side, so we get y is equal to x square by 4. This is number 2. Now to find area between these two curves, we have to solve this equation to evaluate point of intersection. So from 1 and 2, the right hand side of both equations, first equation to root x, we take equal to right hand side of second equation x square by 4. Now we have to solve this equation by factorizing it. As you can observe here, this expression contains radical sign, and to factorize it, for factorization we need a polynomial. That means it does not contain radical sign, that is the index of negative or fraction. So we take square so that the root will get cancelled, but take square on both sides, as this is the equation. On left hand side we get square of 2 is a 4 and root get cancelled with square, so we get 4x. And right hand side there is a quotient, so we take the square of numerator, as x square has a square x raised to 4 and square of denominator 4 square is equal to 16. Now simplifying by this, take 16 on left hand side to get we have 64x is equal to x raised to 4. Now we for first equation having right hand side 0, so that I take 64x on right hand side, so we get 0 on left hand side, and then transfer the term, so we get the equation as x raised to 4 minus 64x is equal to 0. Now factorizing, as these terms are term of x, so the first factor is obvious x and second factor will be x cube minus 64. Now we get two factors. The first factor is x is equal to 0, or second factor x cube minus 64 is equal to 0. As simplifying this, as x cube is equal to 64, as we know the number having cube 64 is a 4, so we get x is equal to 4. So x is equal to 0 and x is equal to 4 are the x coordinate of point of intersection between given two curves, which are our limits of required area between these two curves. So we now evaluate area between two curves. First, A is from with limits 0 to 4 y1 minus y2 into d. As we know, we take this y1 or y2 as terms of x, that means equation of given curve in term of x only. So the first equation of curve is now y is equal to root x, so y1 is in term of x to root x, and second equation of curve in term of x is x square divided by 4. So we have to take integration of subtraction, so that we take separate integration, as in first term 2 is a constant, so it take outside integration, and integration root x is put as a x raised to half. As we know, we take radical sign in a index form, and minus in second term 1 by 4 is a constant, and again integration from 0 to 4 we have x square with respect to x. Now simply taking integration as 2 constant, x raised to 1 half as integration x raised to 3 by 2, as index plus 1 is a half plus 1 is a 3 by 2 with limit 0 to 4, and minus 1 by 4. Here x square has an integration x cube by 3, as index is a 2, we take addition of index 2 plus 1 is a 3. Now 2 by 3 take outside bracket, as 2 is at denominator, so it came into multiplication of numerator, is 2 into 2 4 by 3, and now upper value will become 4 raised to 3 by 2 minus lower value become 0, as lower limit is a 0. In second term, as 1 by 4 into 3 12, as again upper value 4 cube is equal to 64 minus lower value 0 cube is equal to 0. Now simply taking simplification, as 4 raised to 3 by 2 can be simplified as 4 raised to 1 half raised to 3, as we know rule of indices. Actually 4 raised to 1 half is a 2 and 2 raised to 3 is a 8, that is 4 raised to 3 by 2 is 8, and multiplying by this 4 by 3 we get 8 into 4 32 by 3, and minus on second expression as 64 divided by 12. Now simplifying this by equaling denominator on both sides, we divide this fraction by 4, that is 4 into 16 into 4 64, and 4 into 3 12, that is 32 minus 16 by 3, 32 divided by 3 minus 16 by 3, we get 16 by 3 square unit.